To display and control data in dashboards, you can use standard libraries for drawing charts, gauges, switches, and sliders. But what if you need more complex controls, such as a compass or a process diagram? In this video, we demonstrate how to create parametric drawings with JavaScript and Simple Vector Graphics, or SVG. Users can define drawings using special JavaScript functions such as line or circle. The scripts are uploaded to a central server and stored in a database. When a user requests a drawing, the JavaScript code is dynamically executed on the server and an SVG drawing is returned. Let's create a new part for showing an analog clock. We enter the name of the part and click on Create. In this screen, you can enter JavaScript commands to create a drawing. To create the face of the clock, we use a JavaScript loop statement to create 60 small line segments. Each segment is rotated 6 degrees to show the minutes. Drawings can have variables, in this case a variable for the hours and a variable for the minutes. The variables are used to rotate the hands of the clock. We can change the statements inside the loop so that a thick line is displayed for every 5 minutes. Let's change the default values for the hours and minutes. Now that the part is saved on the server, you can generate an SVG by entering a link with the name of the part. The drawing is shown with the default parameters. You can override the default parameters in the link. We can also include the drawing as a part in other drawings. In the part function, we enter the name clock and the arguments for the hours and minutes. In this case, we use the JavaScript date function to get the real-time date and add a text with the name of the city. We can now copy these lines and display the clocks for cities in other time zones. This example shows a compass with a variable for the heading. Instead of embedding the part in another part, we can also create an HTML page where the SVG drawing is embedded as an object. Each compass on the page has a different heading defined in the link to the part. Now let's show how we can combine multiple parts into a primary flight display used in aircraft. We have created a part called Speed Tape that shows the current speed with yellow and red markers. We also have created an artificial horizon that shows the pitch and bank angle of the aircraft. These parts are combined with the compass into a compound display that has 6 different parameters. We can now use this display for dynamic monitoring of the aircraft state. The link for monitoring starts with monitor, followed by an ID of the object and the name of the part. When the link is invoked, the server listens for messages on an MQTT server and dynamically updates the display using server-side event streaming. To test the update of the display, we can use an MQTT client to send messages to the topic defined in the link. The content of the message is an array of values for the parameters defined in the part. This example shows how we can make interactive drawings that can be used as control devices. The drawing shows a seat selector where the user can see which seats are available. The seats that are currently selected are stored in a variable called occupied. When the list of occupied seats include the current seat, the color is set to gray. Selecting seats is implemented with the link function. The argument of the link function is the new state after the user has clicked on the link. In this case, it is the current state, followed by a colon and the label of the selected seat. After editing the seat selector, we can use it as a controller in a web browser or dashboard. The link starts with control, followed by an ID of the object and the name of the drawing. When clicking on a seat, the updated state is sent to an MQTT server. Other software, such as a reservation system, can subscribe to updates of the messages. In this drawing, we show how a user can click in a diagram to control pumps and valves. The state of the devices in the drawing is defined as an object with fields for the pump and the 3 valves. We use the link function to toggle the state of the pump and valves between 0 for off and 1 for on. The color of the lines change between black and blue depending on the state of the pump and valves. When we open the part in a browser, we see that MQTT messages are sent when the user clicks on the pump and the valve. These messages can be used to update the state of the physical devices in the real-world irrigation system.